Question 20, Part A. The diagram shows the curve C with the equation ln 2 minus x and the straight line passing through the axes intercepts and the straight line passing through the axial intercepts of C. Find the exact coordinates of the points where C meets the axes. So we see that this is a straight line. So we know that there are two things I need for a straight line. The first thing I need is a point on the line. And the second thing I need is the gradient. And to find the gradient, I can actually do this because it's a straight line, I can do this if I have 2 points on the line. So, and then that will be using the equation. I think you guys may remember this one. M is equal to y1 minus y2 over x1 minus x2, right? So, what do I do? Well, I actually have 2 points on this line already. I've got this point here and this point here. How do I find them? Well, I know that they are the x and y intercepts of this equation up here. So all I need to do is find the x and y intercept of this equation. So for the x-intercept, I set y equals to 0 to find the x-intercept. So if y equals to 0, I get 0 is equal to ln 2 minus x. Take e on both sides, so I get e to the 0 is equal to 2 minus x. I get x is equal to 1, right? So the x-intercept down here, this value is 1. What about the y-intercept? Well, for the y-intercept, I set x equals to 0. And that gives me y equals to ln 2. So this value up here is ln 2. So I've got these 2 points. I've got the point 1, 0 and the point 0 ln 2 that I know that this curve passes through. So I can take this to be my point on the curve. Now all I need to do is find the gradient. So m equals to y1 minus y2, so ln 2 minus 0 over x1 minus x2. 0 minus 1, I get the gradient to be negative ln 2. So the equation of, oh, wow, okay, so I'm actually going way too far here. I just needed to find the coordinates. So actually, this is my answer here. So please excuse me, sorry, I got a little bit too excited there, started doing a bit too much. These are the coordinates of the points where C meets the axes. Okay, so let's look at the next part. Hence, find the exact area of the region between C and the straight line. Okay, so again, this is ln 2, this is 1, and the region I'm asked to find is this little sliver in here. So, how do I find that? Well, clearly, that's the area beneath this curve C being y equals to ln 2 minus x. It's the area between this curve and, minus the area under the straight line. But the area under the straight line, that's just the triangle, right? So this isn't too bad. What do I get? So the area I'm after is the integral from 0 to 1 of ln 2 minus x dx. Minus away a half times the base, which is 1, times the height of the triangle, which is ln 2. But this is not very good for me, right? Because I don't actually know how to integrate ln. So instead of integrating along the x-axis, I'm going to integrate along the y-axis. So again, remember that this expression up here is my integral of y dx. So if I want to integrate along the y-axis, I need to change this to be the integral of x dy. So this area is actually equal to as a result, you can probably skip this first step. It's not wrong, but you can skip it. The area is actually equal to, from 0 to ln 2 of x. So what is x? Well, y is equal to ln 2 minus x. So x is equal to 2 minus e to the y. Yep. So I integrate 2 minus e to the y dy, and I'm still subtracting away the same area here, minus a half ln 2. So what do I get this time? Well, now this isn't too bad to integrate. Integrate 2 dy, I get 2y. Integrate e to the y dy, I get e to the y. I'm looking at that between 0 and ln 2, minus a half ln 2. So what does that give me? Oh, that gives me 2 ln 2 minus e to the ln 2 is just 2. Take away 2 times 0 minus e to the 0, which is just 1. And that whole thing minus a half ln 2. So that gives me 2 plus 1 will be minus 1, minus 2, minus negative 1. And then I get 2 ln 2 minus half ln 2, so that's plus 3 over 2 ln 2. And so therefore the exact area is 3 over 2 ln 2 minus 1 square units.